Okay, so we have done discussed about different key formulas related to center of gravity, moment of inertia, circular motion, and what is a rigid body, and circular motion that when a vehicle or a car is traveling on a concave surface, convex surface, so what will be the effective reaction, and if a car is moving on a circular path of radius r, what should be the coefficient of friction so that it does not skid and all. Also, even though we have not derived like if a cyclist is going, what should be its banking angle so that it does not skid, and all that we have derived in the previous sessions. We have put the key formulas. Okay, so now based on those key formulas, we will solve some numericals. Okay, so like in that previous session, I was there was a confusion like say if so if if this is a disk, say, okay, so we had a confusion like that the disk the disk, so this is the disk. Okay, so this is there are two diameters, the x and the y are the two diameters of the disk. Okay, so these are the two diameters of the disk. So actually, the moment of inertia of this disk is equal to half mr square, right? So uh, that is actually I was telling that it is about the diameter. Okay, but actually that is not the case. It is not about the diameter, but it is about the axis perpendicular. So z axis. Okay. So if you have the center here, let us say if you look at so x y, so it will be outward. So if it is it's outward. Okay. So about the z axis. So this moment of inertia is about a axis, about an axis perpendicular to the plane of the disk. Plane of the disk. Okay, so this is this is for a disk, and so for a disk actually it is kind of a solid. Everywhere it is filled one, right? Yeah. Okay, so if the same mass, if instead of a disk, if it is a ring, it will become mi ring will become like say mr square. Yeah. Okay. So that is also about perpendicular. So if somebody asks you what is the moment of inertia about the diameter, it will be 1 by 4 mr square. Like it will be half of that. Okay, so Izz will be equal to Ixx plus Iyy, which is equal to 1 by 4 mr square. 1 by 4 mr square plus 1 by 4 mr square, which is equal to 1 by mr square by 2. Yeah. And we were telling about the parallel axis theorem. So now that it is 1 by 4 mr square about say it's 1 by 4 mr square about Ixx, right? Yeah. About Ixx, it is 1 by 4 mr square. So if you draw a tangent, okay? So if somebody asks you what is the moment of inertia about this tangent, let us say this is tt. Okay. Yeah. So ITT, about the tangent, it will be like the distance. Okay. So this distance is, let us say r, right? Radius. Yeah. Okay. So it will become 1 by 4 mr square plus mr square. Okay. So this is so this is your parallel axis theorem. So now you understand disk and ring, and then other than disk you can remember the sphere and rectangle. So rectangle is some value you have to remember, like it is B, it is H, then moment of inertia is equal to about this axis. Okay. Yeah. About this axis, moment of inertia is equal to BHQ by 12. Like if it is, this is XX. Okay. And then if it is YY, So the moment of inertia will become, this is moment of inertia about xx, and moment of inertia about y will be hbqa 12. Right? Right? And then um, and then we have told if you want to find a area moment of inertia of a circle, so that is pi d4 by 64. That is about the diameter, and about the axis perpendicular to it, it will be pi d4 by 32.
32.
Okay. And then we were okay. So that is so we have just given a recap of moment of inertia. So we had just confused about this one. Actually, it is half mr square. For a disk, it is half mr square about an axis perpendicular. And about the diameter, it will be 1 by 4 mr
square.
Okay. So now we will go to the some of the questions. Okay, you can take a picture. Okay, so the question is a rigid body is one. Okay, uh, so a rigid body is one in which the distance between two points does not change. Okay, the distance between all pairs of particles of a rigid body does not change. Okay, there are other options like a body can have only rotational motion, only translation motion. Those are not correct. Okay, so its shape can be deformed. That is not correct. Its shape can be
does not no deformation.
Yeah, and then one question on this is one question on center of gravity. So we'll do one numerical on center of gravity. So the question is like this. Okay, just getting the spec here or under the. Okay. So the x and y coordinate of three particles of mass, okay, 0 0 1 0 minus 2 0. So the question is like this: the x and y coordinates of three particles of masses m, 2m, and 3m are. Okay. So let us draw it. Okay, let us draw it in the coordinate system. Okay, so let us say this is x and this is y. Okay, so you have three particles. Okay, the three particles are m1, m2, and m3. Okay. So the coordinates of these particles are, let us say, the coordinates of these particles are, so one particle is at 0 0. Okay, so this is, let us say, m1. Okay, that so m1, and then another particle is at 1 0. 1 0 means here, means y coordinate 0, x coordinate 1. Then let us say this is m2. Okay, then there is another particle which is at -2 and 0. Okay, there is another particle. So this is 1. Okay, this is 0 0. This is 1 0. If this is 1, this is also 1. So this is -2. Okay, this is +1. So this will be -1. So this will be -2 and 0. Y is 0. Okay. So this is the point where your M3 lies.
Okay.
Okay. So now they are saying M1 is equal to M. Okay. M1 is equal to M. M2 is equal to 2M, 2 times M, and M3 is equal to 3M. Okay, so this is the one. Then the question is the x coordinate of center of mass of the system. Okay, so the x coordinate,
like summation.
x coordinate of CG. CG or center of mass or center of gravity or center of gravity or center of mass, whatever it is. Okay. So you know the x coordinate formula is
From
sigma m I xi.
I
So
from 1 to n.
Divided by sigma
N.
mi, right? So this I starts from 1 to n.
Yeah.
This I starts from 1 to n. So in this case we have three things. So we will do it as like say m1 x1 plus m2 x2 plus m3 x3
by 3.
by m1 plus m2 plus m3. Okay, so that is the x coordinate with respect to origin.
Yeah.
Okay, with respect to origin. So so now we will put x is equal to m1, we will put m. Okay, then x1. Okay, so x1 we know it is equal to 0. Okay, because that is first this thing. Then m2 is 2m and coordinate x coordinate is 1, right? And then m3 is 3m into the coordinate is minus 2, right?
Yeah.
Minus 2. Okay. Then all these things divided by
And
6m.
Yeah.
So 6m. Okay.
This
So this term, so this will become
0
2m. This is 0. So
minus
2m
6m
minus 6m by 6m. Okay.
minus
So
4m.
2 minus 6 by 6. Okay. So minus 4 by 6. So minus 2 by 3. So the x coordinate of center of mass is minus
2 by 3.
minus 2 by 3. So so this is the answer, minus 2 by 3. So similarly, if they ask y coordinate, so you can get the y coordinate also. Like in the question, if y coordinate will be there, m1 y1 plus m2 y2 plus m3 y3, okay, by m1 plus m2 plus m3 plus m2 plus m3. And because everywhere y is 0, all these terms will be 0.
Yeah.
So y will become equal to 0. Okay. And so this is one numerical on center of gravity, concept of center of gravity. Okay. Okay. So another numerical. Okay. So the two bodies of masses m1 and m2 are separated by a distance r. Okay. So this is my m1 and this is my m2, and the distance between them is r. Okay. So the distance between them is r. Okay. The distance of the center of mass of the body from the mass m1 is. Okay. So let us say my center of mass is somewhere here. Okay. So let me assume. Okay. Okay. So what? Okay. So the CG. So we can say that. Let us say this is R1 and let us say this is R2. Okay. Right. So the moment about the CG will be 0. Okay.
Yeah.
When the system is in equilibrium, with the sigma m about CG or any point in the system is equal to 0.
Yeah.
Okay. So so it will, so the writing this equation, so it will become m1 r1 is equal to m2 r2. Why? Because m1 r1 minus m2 r2 is equal to 0, because the total moment in a system in equilibrium will be equal to 0. So m1 r1 is equal to m2 r2. Okay. So so they are asking the distance of the center of mass of the body from mass m1. Okay. So we need to find out r1, right?
Yeah.
From mass m1, distance of CG. Okay. So r1 is equal to, okay, m2 by m1 into r2.
Yeah.
Okay. So, okay. Okay. So, and again, R is equal to R1 plus R2, right?
Yeah.
Okay. So, you wanted to write in terms of this R1, you want to write in terms of M1, M2 and R. Okay.
Okay.
So, you R1 to be written, to be written in terms of M1, M2 and R. Okay. So we are saying that it is R1 is equal to M2 M1 by R2, but R2 we do not know,
We
na.
need R.
Uh, so we have to write it in terms of M2 by M1 is fine, that we know. So R2 we have to find out.
R minus R1 it will be. Then R1 you can take this side.
Okay. So M2 by M1, then
R into R minus R. Capital R minus R1.
but again you are ending up with R1, no?
But you can take. Oh no, you cannot do that. R1 square.
What it will be? Tell. Okay, so okay. So we know that R1 is equal to M2 by M1 into R2, right?
Yeah, we need capital R.
So see this R1. So we know M2 M1 R1 is equal to M2 R2, right?
Yeah.
That implies your M2 by M1 is equal to R1 by R2, right?
Yeah.
So your okay, so and R is equal to R1 plus R2, right? So okay, so R1 we know. Now we have to.
They have not brought in R1, R2 in the question. They've only used R.
They have only used R.
In question itself.
Okay. Okay, so otherwise we can just our understanding is this. For future problem, this is your understanding. Okay. For future problem, this is your understanding that okay, like say R1 is equal to M2 by M1 into R2. Okay. But rather than bringing it this R1 and R2, we can do it in a different way. Okay, so let us say this is my m1, this is my m2, and they are separated by a distance r. Okay, so let me say my CG is somewhere here, it passes through m1. Okay, so if my CG passes through m1, then okay. So let us say this passes through the origin. Okay, then the center of mass will be lying somewhere here. Okay,
Yeah.
right, the center of mass will be lying somewhere here. So okay, so yeah, so let us say this is my center of mass. Okay, so the center of mass, so the coordinate of this center of mass. Okay, so the x coordinate, okay, x coordinate of the center of mass will be like, say, it will be like uh, m1. So center of mass coordinate, x coordinate of the center of mass is equal to, okay, it will be m1 x1 plus m2 x2 divided by m1 plus m2.
Yeah.
Right, so that will be the x coordinate of the center of mass.
Yeah.
Let us say my center of mass is here. Okay,
Yeah.
so that is then I know this my because this is 0, because it is passing through the center of gravity already. So
Yeah.
this is 0. Okay, so this becomes m2 into r, m2 into r, because s2 is nothing but your r.
R.
Okay.
Yeah.
So that divided by m1 plus
plus
m2.
M2.
Okay, so this is the question actually. Okay, so the question is the distance of center of mass from mass m1. Okay, so this is your center of,
We have to find x coordinate.
you have to find the x coordinate. So this is the distance of center of mass.
Okay.
Okay, so this is basically, we can write it as, let us say x. Okay, so I can just write it as xcg. Okay,
Yeah.
so this is xcg. xcg is equal to m1 x1 divided by m1 plus m2, because the first mass is passing through center of gravity, that
It is
moment will be 0, and x2 is equal to r
R.
and this. Okay,
M1 plus M2. Yeah.
so that is a better
That
way of
makes
doing it. Okay, so that is another numerical on the
Center of
moment
gravity.
balance and this.
Center of
You
mass.
can take a picture of it. Okay. So there is another numerical on this. If two masses, okay, so two masses, let us say m1, okay, and m2. Okay, so it is first mass is of 6 unit, okay, 6 unit, okay, and second mass is of, let us say, 2 unit. Okay, 2 unit means it can be 2 kg, it can be 2 gram or whatever. So 2 masses are there, and they are at what position they are given. Okay, so one is 6i minus 7j. So this is at 6i minus 7j. That is the position vector. Okay,
Yeah.
so you know there is that position vector na, in
I know.
vector. That means in x direction it has moved 6, and in y direction it has moved 7. So your vector is like so based on the resultant you will get the vector. So something like this. Okay, right?
Yeah.
This is the vector. So this one position vector is this. At that position one mass is lying, and like that means the mass is lying at like the in x direction in 6
Resultant of those.
resultant of those two. In x direction 6 and in y direction minus 7. Okay, and similarly the other mass is at 2i plus 5j minus 8k. Okay, 2i plus 5j minus 8k. Okay, that is the other mass. So this is, so then they are asking the coordinate of the center of mass. Okay, so coordinate of center of mass.
Find x and
So now for this you know x1 is equal to 6, y1 is equal to minus 7, right?
Yeah.
This is x1 is equal to 2, y1 is equal to 5, sorry x2, right? x2, y2 is equal to 5 and z2 is equal to minus 8. Okay, so these are x1, y1 and this.
And this,
So
this is M1, M2.
this is m1 and 2. So your coordinate will be like say x x center of mass is equal
Find
to
x center of
m1 x1 plus
M2 x2 by M1 plus M2.
m2 x2 divided by m1 plus m2. Okay. Similarly, y center of mass is equal to m1 y1 plus m2 y2 divided by m1 plus m2. Okay. Similarly, z center of mass is equal to m1 z1 plus m2 z2
By M1.
by m1 plus m2.
Yeah.
Okay. So in most of the cases for m1 this z1 is equal to 0.
Zero.
Other two are there. So accordingly you can find out.
Yeah.
Okay. So you can find that out, right?
Yes.
Okay. So that is about the numericals on center of mass. Okay. Then let us do a numerical on equilibrium of rigid body where the principle of moment is being applied. Okay. So it's a numerical on rigid body equilibrium. Okay. Equilibrium of rigid body. Okay. So this is like this. A uniform. So you can draw the picture like this. Okay. A uniform bar of mass m is supported by a pivot at its top. Okay. So this is the one, and then you have a bar. Okay. So you are applying some force F here. Okay. You are applying some force F here. So a uniform bar of mass m is supported by a pivot at its top. So this is the pivot. Okay.
Yeah.
About this pivot it can rotate.
Rotate.
What is a pivot? About that point it can rotate. That is called a pivot. Okay. You know, let's say about which the bar can swing like a pendulum. If a force F is applied perpendicular to the lower end of the bar, so you have applied at lower end of the bar, as shown in figure. What is the value of F in order to hold the bar in equilibrium at an angle theta? So this is theta. Okay. This is theta. So just the question is, so the length of this bar is, let us say, L. Okay. So bar length is L. Okay. So this is length of the bar is L. Okay.
Yeah.
So unless you are applying a force, it will try to fall down. Okay.
Yeah.
So what force you should apply so that it will be under equilibrium?
Okay.
So this you can do it something like this, because this is a bar, the mass will act at the CG of this bar.
Yeah.
Okay, so that's why this length will be L by 2, right? So this length will be L by 2. Okay.
Yeah.
So now you can do it by, like, say the mass, the weight acting here is mg.
Yeah.
Okay. So this mg will have two components. One component is this, like say this is theta means this is theta.
Yeah.
Right? Sorry.
mg
This is
cos
theta means this is also theta, right?
Yeah.
So if this is theta, so this force will be mg cos theta. Mg cos theta. Okay. If this force is mg cos theta, there will be this force also, which will be mg sin theta. Right?
Yeah.
So this mg sin theta into this will be also L by 2, right? This length is also L by 2.
Yeah.
Okay. So this mg sin theta will create a clockwise moment,
Yeah.
whereas your force has to create a anti-clockwise moment.
Yeah.
Okay. So the governing principle of this is the again principle of statics.
Okay.
Okay. Principle of statics says sigma f is equal to 0. That means a body will be in static equilibrium
If the force
if the resultant force is 0 and if the resultant moment is also 0.
Okay.
Okay, so this, let us say this pivot point is A. Okay, O. Okay, so the moment about the pivot point MO is equal to 0. Okay, that means what is the moment here? Like say F into L, the total length.
Yeah.
So that is one moment. Anti-clockwise moment we normally call positive. Clockwise we call negative. So FL minus mg sin theta into L by 2. Okay.
Yeah.
So this is equal to 0.
0.
So that means F is equal to mg sin theta
By
into L by 2 divided by L. Right?
Yeah.
So this becomes mg sin theta
by 2.
by 2. So this is the answer. So if you apply mg sin theta by 2 force,
it will stay in equilibrium.
it will stay in equilibrium. Okay, otherwise it will try to fall down. Okay. Okay, so you can take a picture of this. Then we'll go to the next numerical. Okay, so one numerical on this moment of inertia. Okay. So this is about equilibrium of rigid body. Then we will do another numerical on moment of inertia. Okay.
Yeah. Yeah.
So the question is, the moment of inertia of a circular ring of radius r and mass m about its diameter is. Okay, so this is just a memory question. Okay, so so this is a ring. Okay, so this is my ring. Okay,
Yeah.
this is my ring, and this mass, this is my center of the ring, this is my radius. Okay, and this mass of this ring is m. Mass of the ring is m, right?
Yeah.
So my moment of inertia about an axis perpendicular to this ring. Okay, this about an perpendicular moment of inertia about, let us say this is
ring.
this is xx, this is let us
Y.
say yy. These are the two diameter yy.
Yeah.
So and this is z.
Inward.
So moment of inertia about z is equal to
Moment of inertia
is equal to mr square.
Yeah.
This is the moment of inertia about z. But the question here is the moment of inertia of the circular ring of radius r about the diameter. Okay. So diameter means either ixx.
So half mr.
Moment of inertia about dia is equal to mi
or
xx
or mi
or mi yy is equal to
half
mi zz divided by 2.
2.
So it is mr square by 2. That is the answer. Take a picture.
In this case, both of them are same.
Haan.
MIXX and MIY.
Both are same. Whether disk, so this is ring, okay?
Yeah.
In case of disk, it will be half mr square.
Yeah.
And the about diameter, it will be 1 by 4
4
mr.
MR square. Yeah.
Okay.
Yeah.
So why this disk is half of that ring? Because in disk, in ring you are pushing all the material
Towards
towards
the side. Only the
end.
rim has mass.
So
Here it is distributed.
when this ring becomes a disk, when the ring
Mass is
becomes a
equally
disk,
distributed.
so effectively the mass will be at the half of the center.
It will be distributed.
It will be distributed, but the effective mass will be at the half of the radius.
Yeah.
Understood?
There
That's
it is
why.
only at the corner.
So in ring it is mr square, but in case of disk it will, because it will be at
Towards the center.
towards the center and at the half.
Equally toward.
Equally means it, so if you move everything as a ring, it will be at the radius. But if everything is filled, then that means it will
At
be at the
half the
center.
difference, it will at center.
So that's why one is mr square and other one is half mr square. So this is your ring, okay? This is your disk, okay? And this is your about zz axis. This is also zz axis.
Yeah.
So if you want to find it about the diameter, you have to divide it by
2.
2. Okay? Take it. Okay.
Yeah.
So this is another numerical on moment of inertia. Okay?
Yeah.
Okay, so there is, we'll do one more numerical on. I think there are a lot of questions in moment of inertia.
Yeah.
So we'll do one more. Okay. So the question: if the moment of inertia of a disk about an axis tangential and parallel to its surface, okay, about an axis tangential, if the moment of inertia of a disk about an axis tangential and parallel to its surface be I, then the moment of inertia about an axis tangential but perpendicular to its surface will be. Okay. If the moment of inertia okay, so the moment of inertia about, so you know one is 1 by 4 mr square, another is 1 by 2 mr square, right? This is for a disk, right?
Yeah.
So this 1 by 4 mr square is about the dia, okay, about diameter, right?
Yeah.
About dia, and half mr square is about perpendicular,
Yeah.
perpendicular axis.
Z axis.
So this is your ring, and say this is your this is above dia, it is 1 by 4 mr square, right? And about this this axis, about this let us say this is x, this is y, and let us say this is your z. So about z axis, it is half mr square. Okay.
Yeah.
So about an axis which is tangent to this. So
And
if you want to find the moment of inertia about a axis tangent to the disc. That
Yeah,
means
parallel
tangent
axis.
to the disc and parallel to your diameter.
Parallel axis theorem.
Parallel axis theorem. So mi about tangent is equal to mr square plus 1 by 4 mr square, right?
Yeah.
That will become 5 by 4 mr square. Okay, so that is 5 by 4 mr square. Okay, so using this concept, you can using this parallel axis theorem, whatever numerical can come, you can solve actually.
Yeah.
There can be a number of numerical found based on this parallel axis theorem, and they can twist the problem, but you understand the concept. That is important. Okay. There are so many numericals in parallel axis, the moment of inertia. So two metallic discs A and B of densities D1 and D2 respectively. Okay, so let us say this is a disc and let us say this is a disc. Okay, so I have two discs. So and these two discs, two metallic discs A and B. Okay, so this is disc A and let us say this is disc B. Okay, so two metallic discs and their densities are D1 and D2. So this is density D1 and this is density D2. Density D2. Okay, so these are the two discs. Density D1 and D2 respectively possess same mass and thickness. Okay, so these two have same mass. So M1 and M2 are same. So M1 is equal to M2. Okay, so these two discs have same mass. Okay. Okay. If I1 and I2 are moment of inertia of A and B respectively, then how I1 and I2 are related? Okay. In terms of density, we have to say. Okay.
Yeah.
So relationship between, so this is I1 and this is I2. Okay. So okay, so I moment of inertia, so this mass are same and mass and thickness. Okay. Same mass and same thickness. Okay, so we are not, so let the radius of this disc is R1, okay? Let the radius of this disc is R2, okay? Okay, so if this is the case, okay, then moment of inertia of this is I1, see? I1 is equal to, let us say about the perpendicular axis we will say. So for disc it will be m by 2 R1 square. Right?
Yeah.
M by 2 R1 square and the moment of inertia I2 is equal to mass are same or mass are not same?
Mass are same.
Mass
M1
are
is
same.
equal to M2.
Okay, we have told m1 is equal to m2.
Yeah.
Okay. So
That
I2
is
is
M.
equal to m2, m by 2,
R2 square.
r2 square. Okay. So then this mass
They've told that radius is different.
radius is different. Okay. So now we know that I1 by I2 is equal to
R1 square by R2 square.
okay. So m by 2 cancels out, right?
Yeah.
Mass is same. So this is just R1 square by R2 square. That's all. That's the relationship.
Yeah.
So if you want to write it in terms of diameter, that also you can do. So
dy.
R1 is nothing but your d1 by 2, capital D1 is d1 by 2 whole square, right?
Yeah.
Then d2 by 2 whole
Whole
square.
square.
So you can, if you know the relationship between diameter, you can write one moment of inertia in terms of the other.
Yeah.
Okay. So that's how we'll do it. Okay. So this is so a lot of numericals on moment of inertia. So this disc and ring, these values you need to remember.
Yeah.
Okay. So only one more numerical will do. Okay. Okay. So try to do another numerical on rigid body and statics. Okay. So in a ladder of mass m. Okay. So you have a ladder of mass m. So here coefficient of friction also is coming into picture. So this ladder has mass m. Ladder of mass m.
Yeah.
Mass m. A ladder of mass m is shown leaning against a wall, and this angle is, let us say, theta. Okay.
Yeah.
So this angle is theta, and okay, let us try to draw it the other way. Okay, so this is the angle theta. Okay, this is your ladder. Okay. Okay. And then the coefficient of friction on this surface is mu1, on this surface is mu2.
Okay. Different surfaces.
Two different surfaces. In this figure, it so ladder of mass m shows leaning against a wall. It is in static equilibrium, making an angle theta with the horizontal floor. The coefficient of friction between the wall and the ladder is m1. That between the floor and the ladder is mu2. The normal reaction of the wall and the ladder is n1. Okay, so there will be a normal reaction. Okay, so when something is touching, there will be a normal reaction n1. Okay, and on the floor is n2. Okay, so there will be another, here also there will be one normal reaction. Okay, n2. Then if the ladder is about to slip, means just it is then which condition will get satisfied. Okay. So there will be some certain condition, 4 conditions will be given. You have to solve this problem and say that okay, which condition applies here.
For it to sleep.
Just before sleeping. Okay. So actually when it is trying to sleep. Okay, when it is just trying to sleep, there will be a frictional force opposite to that, because of the weight it will try to sleep. So there will be a frictional force. Let us say that force is F1. Okay.
Yeah.
That F1 will be opposing. So it will, because of the weight, it will try to sleep.
Okay.
So the frictional force will
Try to
oppose that. Okay.
Okay.
So that frictional force F1 will nothing but mu1 into n1, right?
Yeah.
mu1 into n1, and when this one, when is trying to sleep, it will try to come in this direction.
Understood.
So when it is coming in this direction, there will be another frictional force acting here.
F2.
Okay, so which is nothing but your mu2 into n2.
Yeah.
Right. So these are the two F1. Okay.
Opposing forces.
Opposing force. Okay. And now that this ladder will have a mass m. Okay. So this mass m, mg will act here. Okay. So that mg will act here.
Yeah.
Okay. So now we can use any of the moment balance equation to find out to one of the condition. Okay. So let us say this is my point A, and let us say this is my point B. Okay, this is A, this is B.
Yeah.
Okay. Then we can take either moment about A or we can take moment about B. Okay, so let us take the moment about A should be equal to 0. Right?
Yeah.
Because summation of moment is equal to 0. Okay. So about this point, what will be the moment? See this yeah, so okay, so you know this length is L. See this, you know this length is L. That means this will be L sin theta, right? Right?
Yeah.
This this vertical side will be L sin theta,
Okay.
right? And this horizontal side will be L cos theta. Okay. So if you are saying my moment about A is equal to 0, that means your N1 into L sin theta, right?
Yeah.
N1 into L sin theta, okay, that is one force. Similarly, that frictional force,
Yeah.
okay, that
They'll be the same, nu1, n1.
okay. Anyway, frictional force will pass to this point. So this mg, this force will also cause a moment about this. Okay. So n1 into L sin theta minus mg into L by 2 cos theta is equal to 0. So how you get it? So mg will act here. Okay. Okay. Then you know this value is L by 2, right?
Yes.
This is L by 2. Okay.
That is L by 2 cos
If this
theta.
is L by 2, this value will become L by 2 cos theta.
Okay.
So this about point A, mg will cause a moment
L by 2
and
cos theta.
n1 will cause a moment. Okay. So this mg will try to rotate it like this, whereas m1 will try to rotate it like this.
This way it will fall and
So
then this way.
n1 will try to rotate it like this because
It will slip.
It will the moment the n1 force. So you have a n1 force. Okay. So this n1 is the reaction force.
Understood.
So n1 will try to about this point it will try to rotate it like this, whereas mg will try to rotate
because
it like
it has to fall like this.
So these two things. Okay. Any other force? So mg n1. Okay. Okay.
And that weight is also pulling it down.
Okay, so F1 is equal to 0, okay. So, okay. A and D, mu1 the various forces acting on the ladder, let L be the length of the, since the ladder is about to slip, so both the frictions will be limiting, okay. Okay, so they have given that this mu1 is equal to 0. There is so in this numerical, in this condition, he has given the various conditions. Okay, so out of these conditions, if you see this mu1 and mu1, A and D, so B and C are already eliminated, and A and D mu1 is given equal to 0. Okay, so that's what I was wondering, like this frictional force will be there, So this frictional force will also have a moment arm, that will be L cos theta.
Yeah.
But this frictional force is nothing but your mu1 into n1, right?
Yeah.
So in
Same
one
way
of the
that F2 is also equal to nu2 into N2.
So this mu1 in one option is given as 0.
So
So
F1
if
is
this one
0.
is 0, so because this force is 0, then that will not cause any moment here.
Understood.
So if that
It
is
is
not,
only mgl by 2 cos theta.
so then it will become n1 tan theta is equal to mg by 2. So n1 tan theta will be equal to, so sin theta by cos theta, it will simplify
Yeah,
it.
understood.
N1 tan theta is equal to mg by 2. Okay. So this is the thing. And then okay. For force equilibrium, okay. So for force equilibrium, F1 is equal to mu n1, mu1 into n1, right?
Yeah.
And F2 is equal to here.
Nu2 N2.
This is your force F2. F2 is equal to, so this is mu2 n2, okay. Horizontal and vertical direction. F2 minus n1, okay. So what is happening? So the complete system, if you see, complete system, sigma my is equal to 0 and sigma mx is equal to 0, right? Sorry, fy is equal to 0 and sigma fx is equal to 0, okay.
Yeah.
So we have done the moment balance. Now the force balance, like say F2 and N1, they should balance each other.
Yeah.
N1, so F2 minus N1 is equal to 0. Similarly,
Understood.
F1 and N2, okay. So F1 and N2, F2, okay. So this N2 is equal to mg, right? Because this is your N2 and this has to balance this, okay. So okay, so let us
You have to eliminate from options only.
okay. Taking force equilibrium in horizontal and vertical direction. So in horizontal, your N1 and F2 are acting. So F2 minus N1 is equal to 0, right? In horizontal direction.
Yeah.
F2 minus N1 is equal to 0. That is in horizontal direction. Okay.
Yeah.
Similarly, in vertical direction, which are acting equal to 0, that implies in
F1.
vertical direction your F1 is acting.
But F1 is 0.
It is 0. No, but let us write it first. Okay, F1 is acting and mg also is acting, right?
Yeah.
Mg. Okay. And F1 mg, and what else is acting?
N2. No.
N2 is acting, right?
Yeah.
So these three things are equal to 0. But F1 is equal to 0, that we know. Okay, that means N2 minus mg is equal to 0. So N2 is equal to mg. Okay, so that is one condition. N2 is equal to 0. So with all these conditions you can solve actually. We will not, so that is the basically understanding. The force equilibrium, the moment equilibrium. If you get into the choices, you can.
Yeah.
So one thing is, in one of the condition it is given nu1 is equal to 0.
So
that means F1 is equal to 0. So this where you have three forces, that gets simplified. Okay.
If you get nu1 is 0, you've simplified this moment A. So from there only you can eliminate.
So the main point is, when you get a problem like this, first you have to draw the free body. Okay. So the free body is something like this is my ladder. Okay.
Yeah.
So you remove this support. Okay. This is my ladder. On this ladder, I will have two reaction forces. I will have one weight.
Center of
Okay. So I will have one weight. I will have two reaction forces, and because it will try to go down, I will have one frictional force, and because it will try to move slide like this, I will have another frictional force F1 F2. So with so about this point or about this point, about any point moment will be zero. Normally we take either this or this because two forces will pass through this.
Yeah.
That's why two moments will get zero.
Yeah.
That's why we take moment about either this point or this point. So moment about any point is equal to 0 and sigma fx is equal to 0, which are like this force, this force, this force.
Yeah.
And sigma fy is equal to 0. Okay, so that is this force and this force.
Understood.
So you know that normal reaction like mg is equal to this. Okay.
Yeah.
So so the okay so okay, so with this concept you can solve any problem in statics. Okay.
Yeah,
So now we have done problems on moment of inertia, problems on center of gravity, problems on rigid body equilibrium. These are otherwise called these problems in statics. Okay.
Yeah. This is only rigid body.
Rigid body. So there can be lot of numerical. Just remember all those moment of inertia, parallel axis, perpendicular axis theorem. All those things you remember and practice. Main is understanding of the concept. Statics is all about sigma
Fx is
sigma
equal to
f is equal to 0, sigma m is equal
and
to
free
0.
body.
That's all. That is statics. And then
Drawing
your
the
dynamics is about that force is
Equation
equal
of
to ma. Okay. So when there is some acceleration. Okay. Okay.